Okay, so today we're going to talk about section 2, which is talking about different types of energy. And so we are going to focus on the law of conservation of energy and mechanical energy specifically. So, changing forms of energy. We know that energy can change from one form to the next. And so if you're think about energy as kind of a race car, and your body uses energy or food to propel yourself. So as we have the sun warming our skin on a summer day, we have a transfer of thermal energy from radiant energy from the sun. But we have also the chemical energy from plants, which was on radiant energy from the sun, now becoming the fuel, which allows our bodies to have kinetic energy. So these situations involve changing energy from one form to another. And so we are able to do that within our bodies, and also we're able to do that in nature all the time. So here's an example of light. So we see that the electrical energy from the outlet is now changing into light energy and thermal energy. And honestly, with the lights in our classroom, you can hear a low hum. So it's also turning into sound energy. And so we can see that energy is typically transferred in more than one form. Light and heat, or thermal energy, are typically energies that are waste energies because we see them as a byproduct of what we're actually trying to get. But in the case of a light bulb, we're actually trying to get light. And so we can see that we can have a transfer of that electrical energy, and you can feel the warmth of that light. Now, LEDs will produce less thermal energy and more light. It doesn't mean that it's still not producing that thermal energy. It just means it's producing it more efficiently than a fluorescent light bulb. Okay, so fuel stored in energy is a form of chemical potential energy. This would be like gasoline. And so once you have it in your engine or your car and you start your car, your engine is able to transform that chemical energy or chemical potential energy stored in the gasoline into kinetic energy. A byproduct will also be thermal energy. This is why your car heats up in the winter. And so this, we have several energy conversions that must occur within this process. And so here's one of the first ones. So in your car, you have these things called spark plugs. If they go bad, you have to replace them. They're going to initiate the first conversion of chemical potential energy into thermal energy. And what happens is the spark plug in a piston will fire. And you can see at the very top, you have a little light here. This is the spark plug firing. Once it fires and it's compressed, the hot gas will expand and thermal energy is converted into kinetic energy because the molecules are moving so fast that they spread apart, and you can see the combustion reaction occurring here in that gas, and you can see that the piston at the bottom is starting to move. Now, some of that energy, we don't want to say that it's lost completely, but it is transferred. And so we'll see as a result, because we do not lose any energy, just remember that we don't lose any energy, we might see some visible motion, have sound, heat, light. These are all things that can happen. Now, every green plant that you would see conserves light energy from the sun and converts it into chemical bonds stored in the plant called glucose. This is done in a process known as photosynthesis. So we do have a conservation between kinetic and potential energy. You can't just lose potential energy when you go to energy in motion. You may have experienced this in several situations within your life. And so basically, to understand that energy is conserved, that can occur, that's helpful to you. We call this mechanical energy of a system. So we can identify where everything's going and to transfer it. Mechanical energy is the combination of potential and kinetic for the system. And so it's the total amount and can be expressed in the following equation. This equation can be written onto your note cards so you guys have it to use. So let's talk about falling objects. Now we know falling objects like tree have a gravitational potential energy. They're being pulled down to Earth at 9.8 meters per second squared. That's called acceleration due to gravity. The instant the apple comes loose from the tree, it accelerates because of gravity and falls to the ground. Now hopefully we don't have a lot of air resistance acting on it. As it falls, it loses its height, therefore decreasing the gravitational potential energy and transforming that into kinetic energy because it's moving and its velocity is increasing. If the potential energy is being converted into kinetic energy, then the mechanical energy of the object does not change as it falls because it's a combination. So as one goes up, the other goes down. They should always equal the mechanical energy. Therefore, if you're given mechanical energy for an equation and asked to find something like the velocity of the apple falling, you can set the mechanical energy equal to Ke plus Pe, and you can solve for mechanical energy as long as you have the mass of the object and the height at which it started. And the potential energy would not be lost. It is completely converted into kinetic energy. And so the forms of energy can change back and forth, but the amount of energy should remain the same for the entire system. So let's talk about projectile motion, baseball. And so as you can see here, we have a hitter, and he is hitting a baseball. When he hits it initially, it has low gravitational potential energy, and it has high kinetic energy. As it reaches its highest point in its arch, it is going to have low kinetic energy and high gravitational potential energy. And actually, for a split second, it's almost going to stop before it comes back to Earth with high kinetic energy and low gravitational potential energy. Now, if you think about this, when you guys did your experiments with Newton's laws, you had one where you had pennies sitting on a little piece of paper, and then you tried to yank the paper out, and the pennies would all fall in the cup. The pennies actually stay there for a split second, have high GPE or gravitational potential energy and low kinetic energy because they're actually stopped. At the top you stop and then you'll fall back down, even as slightly as it may be. But the energy is transferred in this projectile motion. It forms a curved path, and it is never losing potential. Now you're going to do a pendulum lab showing the same thing. When the pendulum is at its highest point, it'll actually stop for a split second, giving it the highest amount of GPE and the lowest amount of Ke before it swings back the other direction. Same idea. The mechanical energy of the ball will remain the same because as you're increasing Ke, you're losing GPE, and so on and so forth, and so you do not lose mechanical energy. That remains constant for the entire system. Okay, when you ride on a swing, again a pendulum, you will almost feel like you're falling. You're going to drop from the highest point to the lowest point of the swing. Now the highest point, when you're up here, you're actually stopping for a split second, giving yourself the highest amount of gravitational potential energy before you come back down to the center where you're going to have the lowest amount of gravitational potential energy and the highest amount of kinetic energy. Kind of like a pendulum doing the same thing. Energy is transferred in the swing, but is never lost. So when you start, you'll get a push, start moving. That's giving you kinetic energy from your potential. As the swing rises, you lose speed but gain height. The energy, in terms of kinetic energy, changes into gravitational potential energy, and gravitational potential energy will turn into kinetic energy as you go back. At the top of your path, your potential energy is the greatest, and you have the lowest kinetic energy at this point. As you swing your acceleration downward, the potential energy will decrease and change into kinetic energy at the bottom. This also follows the law of conservation of energy. This states that energy cannot be lost, it can only be transferred from one form to another. So the total amount of energy will never change within a system. It'll just be transferred. Even when energy changes from electrical energy to thermal and light energy, you will never see it destroyed. You will only see it being transferred from one form to the next. So with a hairdryer, you're going to see that it turns into not only electrical energy, will turn not only into thermal energy, but it'll turn into kinetic energy because it's moving air, and it'll turn into sound energy. And if you let your hairdryer, depending on the quality of your hairdryer, heat up, you can actually look inside and you can see some of it turning into light energy because you see the coils turn bright red on the inside of it. Now, this principle is a law of nature, which means it always happens. And so we know that it cannot be created or destroyed, and that this is going to be conserved no matter what. So this is a universal principle that describes how energy can be transferred from one form to the next. Remember, just because it's electrical energy to start with doesn't mean it can't be transferred into 3 or more forms of energy. So, is it always conserved? So think about this. While you're coasting along on a flat road on a bicycle, you know that you'll eventually stop if you don't pedal. Are you really conserving energy? You can pause and answer that question within your group. So, if the energy is conserved, wouldn't the kinetic energy stay constant so that you would coast forever? Well, not exactly. Because you have something called friction acting on you. So, you might be turning kinetic energy on your bike as you pedal, you're turning your potential energy into kinetic energy on the bike, but you also have this thing called friction acting against you. So, according to Newton's laws, unless acted on by an outside force, you'll keep going. Well, guess what? Friction's an outside force. So, even if you're on a swing and someone's pushing you, you'll eventually stop swinging. And this is because you are having friction act on you and also gravity. So in other words, mechanical energy, which is kinetic and potential energy, of the swing seems to decrease as the energy is it being destroyed, and is this violating the law of conservation of energy? Well, the answer is no. Every time the ropes of the swing or chains on the hooks or pushing on the air of the rider, you're also having friction or air resistance cause this to change. Now, if you go up to the very top of your swing and you feel those hooks or ropes, you're going to see that they get hot because it's transferring kinetic energy into thermal energy, just like when you rub your hands together. So we're not really losing it, rather it's being transformed into different types of energy as we go through. So we also have this special kind of energy called nuclear fusion. This takes place in the sun, this takes place in stars, and basically we have small amounts of mass that is transformed tremendous amounts of energy. So when 2 hydrogen atoms smash into each other to make helium, energy is produced from this, which we know is radiant energy from the sun. In this reaction shown here, the nuclei of hydrogen isotopes, and I'm not making that up, by the way, the hydrogen isotope of deuterium and tritium are undergoing fusion. So basically what we see here is these isotopes are smashing into each other and they're making a new atom called helium. Deuterium is basically hydrogen with 1 neutron. So nuclear fission is the opposite. This is where you have amounts released, and the total amount of the energy before the total amount of energy before the reaction will equal the total amount after the reaction, following the law of conservation of energy. And basically what you have is splitting of atoms. We use nuclear fission in nuclear reactors, and uranium is a perfect example of this because uranium is used to make nuclear power. By the way, side note, closest nuclear power plant, anyone guess? It's in Minnesota. Okay, the human body is also using this type of energy. We call our energy food. So what forms of energy can you find in the human body? So you can pause this right now and you can talk about them. Okay, when your right hand reaches up to feel your shoulder, you're using a simple action. This is potential energy. You have chemical energy, which is stored within your body, which is converted into that moving arm. You will also see that you have electrical impulses going through your body, thermal energy being produced in your body, sound energy being produced in your body. We don't see light. Nobody glows. Sorry, no light energy being produced in your body. But we have all these different reactions occurring within our body. And so we do see this. And so this chemical potential energy is usually stored to maintain our internal temperature, which is 98.6 degrees. We will also see a portion of this will be given off to the surroundings as heat. And we'll continue this video in a second.